Hello everybody, welcome back to my channel. Let's get started on today's problem. This is from the Thomas Calculus book. So we have that the line that is normal to the curve x squared plus 2xy minus 3y squared equals to 0 at 1, 1 intersects the curve at what other point? So the normal of the curve is just perpendicular. Normal means perpendicular. So let's start off by differentiating the equation of the curve. So to differentiate x squared, we have just 2x plus, take the 2 outside, differentiate x, the product rule, so we have x times the differentiation of y, which is going to be 1 times dy by dx, so times dy by dx, plus y times differentiate x, we get 1, so y times 1, minus differentiate 3y squared, take the 2 from the exponent, multiply with 3, get 6, reduce the exponent by 1, y, and since it's y, you multiply by dy by dx, and equal to 0. Now we keep going. So 2x plus 2 times x times dy by dx, and we have 2 times y, so plus 2y minus 6y times dy by dx equals to 0. We can factor out the dy by dx for 2 of the terms, so we have 2x minus 6y plus 2x plus 2y equals to 0. So dy by dx of 2x minus 6y is equal to minus 2x minus 2y. So dy by dx is equal to minus 2x minus 2y divided by 2x minus 6y. And we can factor out the negative 2 outside. So we would have x plus y, and we'll factor out just the 2 out here. So we have x minus 3y. If we cancel these, you'll get negative 1. So we'll multiply the negative 1 to the denominator to make things a little easier. So we have x plus y divided by 3y minus x. So we just differentiated the equation of the curve, and if we plug in the point 1, 1, we can find the slope at that point by plugging it into this equation. So we have x is equal to 1, and we have y is equal to 1, divided by 3 times y, so that's going to be 3, and minus x is going to be 1, so we have 2 divided by 2, and that is 1. But so this is actually going to be the slope of the line that is tangent to the curve, but they're asking line that's normal to the curve, and normal is perpendicular to the tangent. So the slope of a line that's perpendicular to another line is the negative reciprocal. So if the slope of the tangent is 1, the slope of the normal is going to be negative 1. So let's get rid of everything here. So we have that it hits the point at 1, 1, and we have that the slope, I'm just going to say m, is going to be negative 1. So we have a point and a slope. We can use the point slope theorem to find the equation of the normal. So you have y2 minus y1 equals m, the slope, x2 minus x1. So let's plug in the values. I'm just going to put this as y minus 1 equals the slope, negative 1, x minus 1. So y minus 1 equals minus x plus 1, y equals minus x plus 2. You can just write this as 2 minus x, but you can write this as minus x plus 2. So now we have the equation of the line that's normal to the curve, and they're asking at what other point it intersects. They mentioned that 1, 1 is one point that the normal intersects with the curve. They're asking for the other point. So to find the point of intersection, we must match the equation of the normal curve to the equation, the equation of the normal and the equation of the curve. So what we do is put the equation of the curve, x squared plus 2x. We can replace the y with what we have here, 2 minus x. So times 2 minus x minus 3, and replace the y once again with 2 minus x whole squared equals to 0. So x squared plus 4x minus 2x squared minus 3. Before we multiply, we must solve this thing first. So a minus b whole squared can be written as a squared minus 2ab plus b squared equals to 0. So x squared minus 2x squared, it can be written as minus x squared plus 4x. So multiply everything, minus 12 plus 12x minus 3x squared equals 0. So minus x squared minus 3x squared is minus 4x squared. 4x plus 12x is 16x. And minus 12 at the end is equal to 0. Divide everything by negative 4, you'll get x squared minus 4x plus 3. 0 divided by anything is going to be going to be 0. So you can solve this quadratic equation in any way. But what I would do is just find two more numbers that multiply to get 3 and that both have a sum of negative 4. So the two numbers I think about is negative 1 and negative 3. So we have x minus 1 and x minus 3 is equal to 0, which means x can equal to 1 or x can equal to 3. But we already established the point where x is equal to 1. So let's use the point where x is equal to 3. You can plug it in this equation, the equation of the curve, but I prefer you use this equation because it's a lot simple. So we have y minus 2 minus 3, so y is equal to negative 1 when x is 3. So now we have the x and y values of the curve of the other point. So that is going to be 3 comma minus 1. And that's our answer. Thank you.